Hello everyone, my name is Mahmoud. I am a PhD student at the National University of Singapore. Today I am presenting our work on design tools development with a paper titled A Three-Tier Architecture Visual Programming Platform for a Building Lifecycle Data Management, which I co-authored with Sitchin Zhang and Dr. Adrian Chong. The emergence of the Internet of Things, IoT devices, has enabled a massive amount of data, which posed some challenges, such as managing this big data, for example, transferring, storing, pre-processing, wrangling and mining, optimization and controls. Doing this in a robust cyber infrastructure led to the cloud computing paradigm. That is, computing data in place without paying much effort in transferring data to local storages or processing machines. This is done using scalable storage and computational power on demand, and this is maintained by professionals. On the other hand, delivering useful information to different stakeholders based on their application is yet another challenge. We introduce a three-tier architecture web platform that aims at first, making IoT data from the built environment useful to different stakeholders. Second, an open platform for developing and sharing different models amongst end-use programmers. Third, provide flexibility and scalability by separating the platform into 3 distributed layers. First of all, what's the three-tier architecture? Three-tier architecture is a client-server software architecture pattern. It has several potentials in distribution applications. The key aspect here is that it enables the reusability of program components, such as sharing software components at the runtime, also replicating the same components several times, and so on. This pattern consists of 3 main functionally separated layers. The first layer is called presentation layer, which constitutes the user interface side of the application. All human-computer interactions happen on this layer. The second layer is called application layer, which consists of the core engines where component functions and different algorithms run. And finally, the data layer, which consists of database querying, storage, and accessing, and so on. First, to make the IoT data useful to different stakeholders, we identified 3 main categories of users based on their use pattern. Firstly, users who are interested in monitoring the data, such as facility managers and decision makers. Secondly, users who are just input data, such as giving satisfaction feedback or reporting errors. Third, users who are interested in dealing with the raw data, such as energy modelers and data analysts, also are referred to end-use programmers. Based on this categorization, we built 3 main functions. Those are dashboards, embedded input forms, and visual textual programming interface. We introduce a visual textual programming interface that connects building data management with the simulation and data analysis engines on the cloud, with Python and JavaScript being the back end of the interface. Visual programming is one type of programming language that uses boxes and lines to represent functions and data flow as shown here. This is an explanation of how the 3-tier architecture workflows. First, the user interacts only with the presentation layer. He initiates his task or develops his visual programming component. Then he sends the request through the presentation layer to the application layer to access different engines. After that, the application layer requests for the corresponding data from the data layer. After the data is returned back to the application layer runs the simulation engine or any other engines. And the output of the application layer is responded back to the presentation layer in a form of graphs or text or JSON objects and so on. These are two application examples of the platform. The first one on the left is an interface to Python Pandas module, which is a very well-known data analysis library that runs on Python. First, the user uploads the CSV file to the cloud using file upload component. Then the component reads the file and returns the data frame output in a form of HTML table, text or LaTeX, and so on. The second example is an interface to the cloud building energy simulation engine called BuildSimHub, where the user can upload Energy Plus files and run parametric simulation and many other tasks. More examples can be found on the GitHub repo on this link. Currently, the platform is in the final stages of the alpha release, and it will be available as an open source platform. We welcome collaboration in the development of the platform through this GitHub repository. Thank you so much, and stay safe and stay healthy.